a deflationary view of information in physics. This video tackles the notion of information as it's used by physicists. The science writer Philip Ball stresses the importance of what he and others call information. Ball allows the physicist Christopher Fuchs to express his own informationalist view when he writes, Christopher Fuchs' approach argues that quantum states themselves, the entangled state of two photons, say, or even just the spin state of a single photon, don't exist as objective realities. Rather, quantum states represent observers' personal information, expectations, and degrees of belief, he says. According to this position, a photon isn't in both spin up and spin down at one and the same time. Instead, we simply have the information that it can be either in spin state up or spin state down. In other words, until a measurement is made, we simply don't know which state it's in. One may wonder then, what point a realist notion of a spin state would serve, since realist physicists could never know if they were right about what they say. In other words, what's the point of stating the following? Well, this photon is either in spin state up or spin state down, regardless of what we know, or our information. Is it? How could this or any physicist know that? Since we are discussing the state of a photon, let's trace all this back to John Wheeler. John Wheeler on information. The American theoretical physicist John Archibald Wheeler, 1911 to 2008, once wrote the following words. An example of the idea of it from bit, when a photon is absorbed and thereby measured until its absorption, it had no true reality. An unsplittable bit of information is added to what we know about the world, and at the same time, that bit of information determines the structure of one small part of the world. It creates the reality of the time and place of that photon's interaction. Wheeler seemed to be arguing that a photon literally gains its reality when it's absorbed. Thus, if a particular photon gained its reality only when or after it was absorbed, then it mustn't have had any reality before that absorption. So can we now conclude that there simply was no photon before the absorption? Basically, then, Wheeler stressed that the absorption can be seen in informational terms. That is, when the photon was absorbed, then an unsplittable bit of information is added to what we know about the world. Only when the photon was absorbed could we, that is, experimental physicists, gain information about it. Before that, the photon had zero reality because such physicists had zero information about it. In more general terms, Wheeler believed that everything we discover, at least in science or perhaps only physics, is about bits of information. Indeed, Wheeler believed that an object, or what he called an information theoretic entity, is derived from our information. Technically, this is a transformation which Wheeler called it from bit. Thus, we don't have an it, that is, a physical object, until we firstly have a bit, a unit of information. What is and what we know? Philip Ball also quotes the physicist and philosopher of physics Geoffrey Bubb as essentially putting a similar point about information, and quotes him saying, fundamentally a theory about the representation and manipulation of information, not a theory about the mechanics of non-classical waves or particles. This means that there's an important distinction to be made here between what is, that is, regardless of minds, observations, tests, experiments, etc., and the information we have about what is. Fuchs, at least as presented by Ball, also makes it explicit that this stress on information is on a par with philosophical anti-realism when he argues that it isn't an ontic position. Neither Fuchs nor Ball ever mention the philosophical position of anti-realism. It is instead an epistemic, that is, a knowledge-based or information-based position. In Ball's words, Fuchs sees these insights as a necessary corrective to the way quantum information theory has tended to propagate the notion that information is something objective and real, which is to say, ontic. It is amazing how many people talk about information as if it is simply some new kind of objective quantity in physics, like energy, but measured in bits instead of ergs, he says. You'll often hear information spoken of as if it's a new fluid that physics has only recently taken note of. In contrast, he argues, what else can information possibly be except an expression of what we think we know? This means that stuff, in a manner of speaking, gives off information, rather than stuff being information in and of itself. In other words, information as seen in the latter way almost seems like a misuse of the word information. Yet Fuchs's position conflicts with what other philosophers and physicists see as information. Such people believe, as Fuchs himself says, that information is in no way mind-dependent. It is ontic. They believe that information is information regardless of persons, minds, observers/observations, tests, and experiments.